Okay, cool. So, yeah, as I said, what we've done so far is we've talked about what interpretations are, what they look like, how we can use interpretations to define truth and falsity in first order logic. So, importantly, in every instance, when we say that a sentence is true or false, it will always be relativized to an interpretation. So we'll say that this sentence is true on this interpretation, or it's false in this interpretation, or we might talk about truth or falsity in every possible interpretation. And using these notions, we'll then be able to, as I said, define up parallel concepts to the ones that we had for TFL. And in fact, to go back even further, not just concepts parallel with the ones in TFL, but also parallel to the notions we started with back in lecture 1. So that'll be the idea. That's what we're going to do now. So now that we've got truth and falsity in first order logic, we can use it to make sense of semantic notions. And the thing to stress is these are going to be very similar to the stuff we talked about with TFL, but the magic word is different. The core concept that they are defined in terms of is fundamentally different. Because if you remember, for TFL, the core concept was valuations, truth or falsity of atomic sentences. The core concept here is interpretations. That is, extensions of predicates. That is going to be the most important thing when we're building interpretations to test for semantic properties. We care about what is in the domain, what bits from the domain are in the extensions of predicates. We have to fix those, and then everything else will fall out therefrom. So to express this, what we're going to do, we're going to use this double turnstile symbol again. But here, when we have FOL sentences, it's not going to express tautological entailment. Because tautological entailment, if you recall, was defined in terms of valuations. Instead, when we use FOL, this is going to express logical entailment. It's going to be fixed by what's true or false in interpretations. So our first pair of notions that we have, first pair of definitions, we have being a logical truth and being a contradiction. So we will say that an FOL sentence, A, again, A in sexy swash font, so it can be as simple or as complex as we like. Right? A is a logical truth if and only if it's true in every interpretation. So in this case, it must be impossible to construct an interpretation that would make our sentence A false. So there's our first notion. Our second notion is being a contradiction. And we'll say that an FOL sentence A is a contradiction if and only if it's false in every interpretation. So that is, there's no way to build an interpretation that will make this sentence true. Again, these are very parallel to the ones we had before. With TFL, we didn't call these logical truths, we called them tautologies. With TFL, we use the same word, but importantly, a contradiction in FOL and a contradiction in TFL need not be the exact same things. You might be a contradiction for TFL because of the truth functionality, but you could be a contradiction in FOL not because of truth functionality, but instead because there's no way to make the extensions of predicates such that this sentence can be true. So these are our first two definitions. And I'm going to talk to you first about the definitions, give them to you, and then we'll talk about how to use interpretations to show them. But we'll go through these. So there's our first pair. And of course, there's a gap in between. What's the gap in between? well, not just ambiguity, right? What's the term we would use for a sentence in between these two? It's contingent, right? It's contingent. A contingent FOL sentence is one where we can make interpretations where they're true, and we can make interpretations where they're false. Again, paralleling everything we've done so far with this trio. The second notion we can talk about is equivalence. So we can say that two FOL sentences A and B are logically equivalent if and only if they have the same truth value in every interpretation. And this is obviously parallel to the notion of tautological equivalence, but tautological equivalence was same truth value in every valuation. So what this means is that if two sentences are logically equivalent, it's impossible to create an interpretation where they differ in truth value. No matter how hard you work, they'll always be the same. Might be they're both true, might be they're both false, but they're always going to line up together. So there we go. That's, again, our first pair of properties of individual sentences. Next one is property of pairs of sentences. You can probably guess what the next one's going to be, right? Sets of sentences, collections of sentences. We can say FOL sentences A1 through AN are jointly consistent if and only if there's at least one interpretation that makes them all true. And this collection of sentences is jointly inconsistent if and only if there's no interpretation where they're all true together. Note that this is very close to the initial definitions we had of joint consistency and joint inconsistency. But now we've got a technical notion to use instead of just it's possible. We can define what we mean by a space of possibility. It is an interpretation, a fixing of a domain and a fixing of extensions of predicates. That's what we've got here. So we've got necessary truth, necessary falsehood, characterized as being a logical truth or a contradiction. We've got joint equivalency in terms of never having an interpretation where they differ in truth values. We have consistency, where there's at least one interpretation where they're all true. Inconsistency, where there is no such interpretation where they're all true together. Can we already guess what the last notion's going to be? The most important one, the one we start with. We're going to talk about validity. And again, much like with TFL, we have a middleman. Our middleman is the entailment relation. So we will say that A1 through AN logically entails some sentence C, if and only if there's no interpretation that makes A1 through AN true and C false. And that should set off alarm bells. That is just the characterization of validity in terms of interpretations. So we can say that this argument's valid in FOL if and only if there's no interpretation where all premises are true and conclusion false. And it's invalid in FOL if there's even one interpretation that makes premises true and conclusion false. So now, what is this getting us to? This is getting us to a very, very refined concept of having a good logical structure. Because we can now say, all right, we have our truth functionality test with the truth tables, but now we can start to ascribe meanings to the predicates, extensions, objects in the domain that are supposed to satisfy the meanings of the predicates. And now we can start to track things like valid in virtue of meaning, as long as we understand meaning here extensionally. So we have it both ways. We can get it valid in virtue of form using this, and we can also get some valid in virtue of meaning using this by fixing the extensions in the way that we would like. So these are our concepts. Again, logical truth, contradiction, logically equivalent, joint consistency, joint inconsistency, and now validity and invalidity of arguments. And this is the tool. This is the wonderful, wonderful tool that we wanted to drive for. But of course, in order to use it, we need to know how to be able to construct interpretations to test them. So what we're going to do, we'll construct interpretations that show what we're after. This means we specify a domain, we fix the denotations of relevant names, if there are any. We stipulate expressions of the predicates that we're paying attention to, and then we do the evaluation. So for example, if I give you an FOL sentence, and I ask, hey, is this sentence a logical truth, a contradiction, or neither? We could show that it's not a logical truth. How would we show that it's not a logical truth? Well, that would show us both, right? We have to come up with an interpretation that makes it false. That'll show it's not a logical truth. And then we come up with a separate interpretation that makes it true. The first one shows us it's not a logical truth. The second one shows us it's not a contradiction. It's possible to make it true, and it's possible to make it false. Similarly, if we have a pair of sentences, and we want to show that they are not logically equivalent, what would we do? We've got two sentences, A and B, and we want to show that they are not equivalent. How could we do that? Let's think, right? When we were doing TFL, how could we show that two sentences were not tautologically equivalent? Perfect. So let's transliterate that to here. Instead of one valuation, we come up with one interpretation that applies to both sentences, and it will make the sentences have different truth values. If we can come up with even one, we know that they are not equivalent. And how would we show that an argument's invalid? So what will we do if we have an argument in FOL to show that it's invalid? Well, again, let's think about it. What did we do when we had TFL to show that an argument in TFL was invalid? And the premise is true, right? So to show that it was invalid, if we had an argument and we were going to prove that it was not a valid argument, we need one valuation that makes the premises true and the conclusion false. So we'll do the same thing. To show that an argument of FOL is invalid, we come up with one interpretation that applies to the premises and the conclusion. This interpretation will make the premises true and the conclusion false. That's what I'm going to ask you to do. So let's talk about constructing interpretations. The idea here will be to construct these that then test out the various semantic notions that we just defined. So here's our first one. Let's take this FOL sentence and let's show that it's contingent. That is, it's not a logical truth and it's not a contradiction. So what's the task? If we want to show that this sentence is not a logical truth, first things we've got to do, come up with an interpretation that makes the sentence false. And importantly, the sentence main operator is the existential. So in order to make this existential false, we need to ensure that nothing in the domain makes the sentence in the brackets true. Because if there's even one thing that we can plug in for X that makes the sentence true, the existential is true. So we'll build our interpretation with the aim of making the sentence false in mind. To do that, we fix a domain, we will fix the extensions of the relevant predicates, and because there are two names in this sentence, we will need to say what objects in the domain these names stand for. That's just the basic process. Now, if we want everything in the domain to make this embedded sentence false, we will need to make it such that everything in the domain makes the antecedent true and the consequent false. And do we see why? The sentence inside the brackets is a conditional. If even one thing in the domain makes the antecedent false, then that conditional is true, and then our existential is true. So we have to make sure that everything in the domain makes the antecedent true, and nothing in the domain makes the consequent true. It's got to be false. So we can do it this way. Let's have our domain be the Fantastic Mr. Fox and the best of the Robin Hoods. Right? If you haven't seen this movie, please just leave. Go watch the movie now. It's better than anything I'm going to do. Right? Love this movie. So we'll have our domain be these two objects. We will have predicate F. We'll fix the extension of this predicate indirectly. We will say is a fox. Right? So in this case, both objects in our domain satisfy the predicate. And we'll have A named Robin Hood and B named Mr. Fox. So in this case, everything in the domain makes our antecedent true, but A is not B. So our consequent is false, no matter what we plug in. So there is not even a single thing that makes this sentence in the brackets true. So our existential is false. So this tells us this sentence is not a logical truth. It's possible to make it false. But does this show that this sentence is a contradiction? Is it impossible to make this sentence true? Well, let's think, right? Can we come up with an interpretation that makes the sentence true? Well, we can't change the sentence, right? Because if we change the sentence, we're talking about a different FOL sentence. But what we can change is the interpretation. Because this is what we constructed. So we can change the interpretation, change the domain and the extension of the predicate and the mapping of the names to get us a different circumstance, which will make this sentence true. So, here we go. Let's show this sentence is not a contradiction. Come up with an interpretation where the sentence is true. Okay, my domain is Robin Hood. F is a fox. A names Robin. And B names Robin. Right? In this case, is there at least one thing in the domain that makes the embedded sentence true? Yeah, Robin. In fact, everything in the domain makes the embedded sentence true. So, what does this show? This shows that it's possible to make our FOL sentence true. It's not a contradiction. There's at least one interpretation that makes it true. Just like how, to go back a slide, this showed us that there's at least one interpretation that makes this sentence false. So what do we want to do when we're playing around with the truth or falsity of a sentence? Think about building your interpretation. What is your domain? What names stand for, right? What objects in the domain do the names pick out? And what's the extension of the predicates you want to think about? So if I can give you an FOL sentence, you should be able to show me that it is not a logical truth, building an interpretation where it's false, and not a contradiction, by building a different interpretation where it's true. Okay? So there's our first two. Now, what if I give you a pair of sentences? And I ask, hey, show me that these pair of sentences are not equivalent. If we're going to show that they're not equivalent, what does our interpretation need to do? Well, we mentioned it a minute ago, right? If they're not equivalent, it must be possible to make an interpretation where they differ in truth values. So let's build an interpretation like that. Here's two sentences. We want to show that they are not logically equivalent. And we'll do that by making one of them true and one of them false. So we will build an interpretation that does that for us. So here's an interpretation. I'll have my domain be Jake and Robin Hood. I'll have the extension of F. I'll fix it directly in this case. I will list the objects from the domain that are in the extension. The extension of F is Robin, and the extension of G is empty. So how many things from the domain are in the extension of G? None, right? None. Nothing from the domain is in the extension of G. So on this interpretation, our universal claim is false. Why is the universal claim false? On this interpretation, why is the universal claim false? Well, remember, universal says every object in the domain satisfies the sentence, right? So if there's even one object in the domain that makes the embedded sentence false, then the universal is false. Conveniently, we only have two objects. So let's run through them, right? If we plug in Robin for our X, is the embedded sentence true or false? Is Robin an F? Cool. So that side of the disjunction is true. So then what does that make the disjunction? It's true, right? Cool. And now what happens if we plug in Jake for our X? Is Jake an F? Is Jake a G? Uh-oh. Our disjunction is false when we plug in Jake. So there's at least one thing in the domain that makes the embedded sentence false, which means our universal is false on this interpretation. Now, what about over here? Is our existential true or false? It's true, because there's at least one thing that makes the embedded sentence true. So on this interpretation, the universal's false, the existential's true, so it shows that they are not logically equivalent. Again, for this task, you build one interpretation, and it shows that the sentences can have different truth values. Some tips here. Note, one of the things you can do, keep your domain very small. One or two objects. That makes it much easier because you can literally just run through every one of them. The other tip, remember when you're doing the extensions of your predicates, you can fix them directly. You can have them be true of everything in your domain or true of nothing in your domain. Empty predicates are your friends for constructing interpretations. They'll make life very easy. What about showing an argument's invalid? Right? If we have this, we have an argument, we want to show it's invalid. What we do, we construct an interpretation that makes the premises true and the conclusion false. So here's an argument. We're going to show that this argument's invalid. We come up with an interpretation a single interpretation that applies to all the premises and the conclusion, and it, on this interpretation, will make the premises true while our conclusion remains false. So, here we go. Our domain can be Jake and Robin, same domain as before. We'll fix the extension of f directly, and we'll just have it be Robin, and we'll have A named Jake. On this interpretation, our initial premise is true. Why is it true? So what's the main operator of our first premise? It's not the conditional. In our first premise, the main operator is the existential. So we need to find one thing in the domain that will make the conditional true. Right? So what's an easy way to make a conditional true? Make the antecedent false. So if there's even one thing in the domain that makes the antecedent false, the existential will be true. And who is it that makes the antecedent false? It's Jake. Right? So Jake does the job of making this true, given that he is not in the extension of f. Cool. What about our second premise? Is our second premise true or false on this interpretation? It's true. Why is it true? Yeah, right? We can plug some object from the domain, and it will make the x true. Like, who's the object we plug in for x for our second premise? It's Robin, right? It's Robin. So cool, our two premises are true. Is our conclusion true or false? Well, what's the main operator in the conclusion? This time it's the conditional, right? And if we want the conditional to be false, we need the antecedent to be true and the consequent false. So is our consequent true or false on this interpretation? It's false, because the thing named by A is not in the extension of f. Is our antecedent true or false? It's true, because there's an object we can plug in that's an f. And who is the x for this case? Who is our f? Robin. So this shows that this argument is invalid. It is possible to come up with an interpretation where all premises are true and conclusion is false. So again, what are we doing with these cases? I'm giving you various sentences, arguments, and I'm going to task you with showing me that these sentences aren't logical truths or contradictions, that this pair is not equivalent, that this argument is invalid. I'm asking you to construct an interpretation that does these various things. We can also draw diagrammatic interpretations to do the same thing. Here's an argument, right? For every x, there's some y such that x m's y. That means there's some y such that every x m's y. This is just the loves one. This is everybody loves somebody in the two different readings. You can draw the diagram, and the diagram will make the premises true and the conclusion false. Again, it's just another way to do the same thing. So here's an interesting upshot of all of this. Right? If some interpretation makes all of A1 through AN true and C false, then we know the corresponding argument is invalid. We know that these do not logically entail C. And we'll know that A1 through AN negation C is jointly consistent, because there'll be some way to make the premises true and the negation of the conclusion true. Makes sense. Makes sense. In this case, what we're really after when we're thinking about arguments and evaluating them with interpretations is I will always ask you to give me what we'll call a countermodel. A model that shows the premises can be true and the conclusion false. Most of the time when we're dealing with FOL, we're going to be constructing countermodels. So some practical suggestions for interpretations. Mentioned these earlier. Keep your domain very small. 1, 2, 3 objects at most. Remember that you can stipulate extensions of predicates directly or indirectly, whichever is more helpful. Remember that predicates can be empty, applying to nothing in the domain, or to everything in the domain. And if you're dealing with two-place relational predicates, think about drawing diagrammatic interpretations. You don't have to. I'll never force you to. But they can be very helpful. So I want to wrap this bit up by thinking about the limitations of interpretations. Because weirdly, this tool that I'm giving you about building interpretations, there's some things it can't do. So what we can do to show that a sentence is a logical truth or is a contradiction, you have to think about what's true in every interpretation. You need to somehow think about all of the possible interpretations you could construct. The same thing with showing two sentences are equivalent or that an argument is valid. But how would you show this? How would you show that an argument is valid? Well, you'd have to somehow think about every possible interpretation that anyone could ever make. And that's going to use a lot of paper. That's not something we can actually do. In fact, we end up in this situation. If you want to show that a sentence isn't a logical truth, you can get away with one interpretation. But if you want to show it is, you've got to somehow think about every possible interpretation. The same thing with a sentence that is a contradiction. You can show that it isn't very easily. To show that it is, you ain't going to do it with interpretations. And so on with sentences that are equivalent, some sentences that are not consistent, and whether an argument is valid. We somehow need a tool that will let us think about all possible interpretations. And to spoil something, we're not going to get that in the first half of the course. I'm going to give you the stuff that lets us do the all in the second half. What that means, though, for now, is I'm going to ask you how to do the stuff that just requires the one countermodel. So I will ask you questions about, show me that this sentence is not a logical truth, that it is not a contradiction. Show me that these two sentences are not equivalent, and that this argument is invalid. I will never ask you, at least not in the first half, to do any of the ones that say all. Because that's the tool we're going to talk about in the second half. We've got to get there first. So the thing to do first is, again, knowing how to be able to construct interpretations that let us check every one of these that say one. That's what I'm going to ask you on the midterm. So in the cases where we're thinking about all possible interpretations, we can't really do anything yet. We couldn't build just a bunch of interpretations because there's nothing that guarantees we've exhausted all the options. So the best we're going to do is a kind of reconstruction in the meta language, in English. So we could do something where it looks a little bit proofy. But that's what we're going to build to in the second half. Right now, again, the focus is being able to construct single interpretations that do the jobs that we want. Importantly, and very nicely, you're now fluent in FOL. Yay! So actually, it's really, yeah, good for us. So this is also things to note. This is the last new information I'm going to give you before the midterm. What we're going to do in the next week, right? This week we'll talk through all the questions that we have, the tutorials about building interpretations. So we'll focus on how to build interpretations. We'll then next week just review. I'm going to upload the practice midterm today, and that's what we'll work on in next week's tutorials. But come with questions next Monday. We'll talk through everything and prep for the exam, but have a lovely week.